I'm going to go through a couple of examples of listing and identifying the characteristics for a polynomial function. The first characteristic we're going to look at is the degree. Remember that degree is usually the highest exponent on a variable when it's written in an equation, but to find the degree from a graph, the easiest way to do it is by looking at the number of turns that the function makes. So for example, if I'm looking at this function, it's going one direction and then it turns. And then it's going another direction and it turns. And so I would say that this graph is showing two distinct turns. And so what you typically want to do is you want to take the number of turns and add 1, and that'll give you what the degree is. So I can really easily see that this function must be a degree 3 function. In other words, it is a cubic function. The second characteristic that we looked at is domain. That's all of the x values for a particular function. Polynomials are really easy though because they all have the same domain. All of them, you say the domain is negative infinity to positive infinity. And so you never have to think about it or question it. If it's a polynomial function, then this is going to be the domain. There are no restrictions on x. Now, when it's asking for the range, that's all the possible y values. Sometimes this does get limited. It depends on the particular polynomial function. You read the range from bottom to top. And so, like if I look at this graph from the bottom, I know there should be an arrow here to indicate all the negative y values are going to get covered. And then obviously there's all this happening in between here. And then this should probably also have an arrow to show that all the positive y values are going to get covered. So in this particular example, I would say that the range is also negative infinity to positive infinity because all of these values are going to get covered somewhere at some point. When they ask about the zeros of a function, that literally means the x-intercepts. And so I can look at the graph and say, well, it crosses the x-axis here, here, and here. And so I can literally list that as x equals -3, x equals -2, and x equals +2. You could also list these out as actual coordinates. And remember that the word zeros, it means the same thing as x-intercept. It also means the same thing as roots or solutions. And there can be no x-intercepts. There can be just 1. There could be 2. There could be any number of x-intercepts. When we talk about the y-intercept, that's where it's crossing the y-axis. Like right here, I would say, I'm going to say that it crosses at -12. And so I can either write that as y equals -12, or I could write it as a coordinate. I could say that's the point 0, -12. There will always be one and only one y-intercept for any polynomial function. The last characteristic that we looked at was end behavior. And I said this is one of those things that it's written the same way every time. And if you can just get used to the way it's written, then it should be kind of easy to answer this. It always starts off by saying as x approaches positive infinity, f of x approaches, and you would need to fill in a blank. And then it says as x approaches negative infinity, f of x approaches, and again, you'd fill in a blank. These blanks, you're supposed to fill in literally what direction is the function pointing toward. And to know which to put in which one, when it says x approaches positive infinity, well, x is going to positive infinity on the right. So this is talking about literally the right-hand side of the graph. And so I'd say, well, this right-hand side is pointing up, so I'm going to put positive infinity in this blank. When it says as x approaches negative infinity, x is going to negative infinity on the left. So I'd say, well, the left-hand function of this graph is pointing down. So I'd say the function is going to negative infinity when I look at the left-hand side of the graph. And so this is a quick example of how to identify various characteristics of a polynomial function from a graph.